Hey guys, what's up? Danny here, and today I'm gonna be talking about um, Hurricane Lee and a couple other things, right? So currently, Hurricane Lee is kind of making its way uh, northwest. I would say like west northwest, and soon it's gonna start going directly north. Now, it's a very interesting feature on the current latest run of the GFS is that it's showing Lee absolutely hammering Massachusetts, Boston, Nantucket, Rhode Island, Vermont, coastal Maine. Those are the areas that will get hit extremely hard if this model confirms. Now, currently we are only about I would say 6, 7 days out, so these models could be, saying something right now. I'm going to also pull up the Hurricane Lee current ensembles too. I'm going to show you guys that because that's extremely important. And, like, yeah, but, as I keep on going through the GFS run, we got two storms we need to keep an eye on. So there's going to be another hurricane that comes right after Lee. So if I go to the National Hurricane Center. Right, let's just take a look at this, right? So, um, there's gonna be a 10% of cyclone formation next 28 48 hours, and so these two X's basically mean that okay, within the next 7 days there's a 50% chance of a development. Margot is probably going to be out to sea. Lee is currently a, let's see, sustained winds 105 knots. Currently, it's looking like it's a uh, like category 3 hurricane, something like that. So, as you can tell here on the track, it's expected to go north, and obviously right here we got the wind speed and everything. But again, if it just continues completely north, right, Massachusetts and all those states are potentially could get impacted extremely hard. Now, let's just take a look at the North Atlantic view, and here you could see with more detail, right, how Lee is gonna go through and how this next hurricane has a chance of development. So again, the National Hurricane Center, it has a 50% chance of development within the next 7 days from a wave that is currently, let's see, the wave is about currently in like this area, right? So then if you just take a look at it over time, you see how it moves through here, and then this is within like the next 5 days, and again, it starts developing. It's a 50% chance of development. Now this is still a tropical depression, right? Now, realistically speaking, obviously we got this big high pressure guiding all of these systems, right? And as we go through, right, it's real. This other system really starts getting extremely rambunctious, right? As you can tell, the millibars are deepening. This is now a tropical storm to hurricane type of status, right? It's already going through that transition. Now, this is September 18th. National Hurricane Center says 50% chance to develop in the next 5 days. So this is now the next 7 days, right? So the chance of development probably then at that point is probably 100%, right? So we go through and it shows it almost hitting Puerto Rico, Dominican Republic. Now I feel like all of these parts should really look after this up and coming hurricane because let's see, it shows at 936 millibars. So we go back to Lee, and Lee isn't even as strong as this storm is expected to be, and it shows it tracking much further down to the south. Now, as we continue, it shows it impacting the East Coast. Now, this is the thing: the 12Z model run, which is generally more accurate, right? It shows it, taking the same type of track, but then it literally just impacts New York, and this is insane right now. This is showing this hurricane impacting New York at around like category 3 level, and that's a major hurricane type of level, right? So basically what happens is that this high pressure kind of guides, and now currently we are about 2 weeks out of this storm potentially making landfall, but it's definitely something that we should really keep an eye on, with the current weather that's going on right now, because these tropical waves, you could tell they literally come from Africa, and eventually they really develop into something more powerful. So let's take a look at the agreement between the European model and all these other models. So this is the okay, we got the 12Z European right now, and it's showing that same exact hurricane system, but it's developing, but it's like moving north extremely quickly, right? So obviously there's different ensembles that show different things, and the latest European also shows obviously there's going to be, at this point, I think it's safe to say that there's going to be some type of impacts from Massachusetts, Maine, Vermont. Those are the main areas that are most likely to get hit extremely hard by Hurricane Lee, and then we have this second storm and everything. So let me just go here real quick now. We're gonna actually take a look at some of the ensemble members for the okay, let's take a look at the wind shear map. So this is gonna really show you. Okay, so Lee is currently right here. So as you can tell, there's actually a lot of wind shear where it's tracking, and it's gonna continue tracking through a lot of wind shear. And if you look closer towards this area, there's less wind shear, so that's going to give the other hurricane a lot of dynamics to strengthen a lot. And then this other hurricane up here, it's weakening because you see extreme amounts of wind shear. Now the green is very, very low amounts of wind shear. So if we just continue, let's see. I have a couple of things saved through here. Let's see. Hold on. Couple pages here that I really want to show you guys. We got the plumes, enhanced data display. Let's see. Let's just take a look at this COD meteorology, and we could take a look at the GEM GDPS. Long range GEFS. So let's take a look at let's take a look at this. So this is currently the GEFS. Now these aren't the ensembles, right? But let me just pull up the ensemble precip type potentially. Okay, yes, so this is all of the tracks that we could see for Lee, right? And of course Lee is you can see it in all of these members, right, where it's going to be at. So currently, right, wow, there's actually ensemble data that are showing it going onshore. What? Come on, yo! These people be lying on the news that it can't hit. Take a look at the ensemble members of hold on. There's two, 13 and 14 literally show Lee coming onshore and hitting New Jersey and making landfall in New Jersey. That is insane. Now, why is that something? Why is that something that could actually occur? Well, the thing is that like we're still more than 5 days out. When you go more than 5 days out, now that is something that it's like, that's a lot of time, right? When it's a lot of time, right, you really don't know what's going to go on. So again, we're out that much, and the ensemble members, some of them are really showing. I can't click it, but you look at this. That's literally onshore in New Jersey, and that's only a couple of them. That's only a couple of the ensemble members. They're hitting New Jersey. So you take a look at Hurricane Sandy track 5 days before it hit New Jersey. So let's see. What were the okay, I'm not sure if I could put up like those pictures and everything right now, but some of the ensemble members, they were you know okay. Well, when Sandy started, this was even before this type of image, right? When Sandy started, hold on. Yeah, there was like most of the models showed it literally going out completely to sea, and then only when we came closer to the forecast, then it started actually impacting, and it was honestly just freaking insane. So just based off of these GFS models and everything, and so even some of the European recent models and stuff that they were showing that Lee was gonna really impact the Northeast and everything. So yeah, that's the thing, and again you could even to take a look at the GEFS over here if we have it somewhere. Hold on, ensemble the GEFS, right? So we take a look at the ensemble member MSOP. So this is kind of showing where Lee could potentially go, and look at this. That literally confirms whatever that said. So look, we have some of the ensemble members literally like it's so different, and it really depends on the timing of the storm for Lee. Is that if it literally like look at this, we have these just a bundle of these. Look at this, September 16th. We're not even 5 days out, right? Why is this storm actually like have so much potential, right? Because look at the disagreement in these ensembles. If there was a cone that I could draw here, you'll be talking about like it could either go out completely to sea, or it could actually hug the coast. And like even like the latest European model, well, maybe not the latest, well, the one like before, it was so different. Like, hold on, not this one, maybe the 12Z of yesterday. Yeah, look at that, it literally showed it coming on shore in Massachusetts. So still East Coast, please watch out for this. Like, I'm not lying. We take a look at the let's see, icon, and again, it's a little different. That's the 8. Let's take a look at the 12Z, because here you could definitely probably see, and it's showing that bow effect. Look at what Sandy did, right? Why is that happening? So this is not just on the GFS. This is the icon model, right? So if we go back to what the GFS is showing and what some of the ensemble. Okay, wait, hold on. So the GEEPS. Let's take a look at those ensemble members of the current 12Z run. Okay, so this could be brand new data, fresh data that's coming in right now. Ensemble member MSOP. So this is the Canadian, and now it's showing basically everything kind of going out to sea, and maybe some impacts for Massachusetts, but again, okay, it's showing all that going on, but this is the latest run of the GFS that's kind of showing it closer. So let's analyze this even further. See the EPS. I think this is the European model ensemble. So again, showing some of these ensemble members kind of coming closer to shore, but then just based on the icon model and everything like that, there's some type of curvature going on. So what does that mean in the atmosphere? So let's zoom out again. Let's pan out a little bit into the North Atlantic, and wait, no, let's go to the main CONUS of the U.S. and then let's take a look at the troughs, right? What's going on in the upper air, and this is going to determine everything. So this is the thing. Yeah, the GFS, the latest one, right? So it shows this storm completely missing the trough, right? So it doesn't take it up. So these are like the two scenarios that could happen, right? The European. Yeah, that's the thing, is that recently the models are kind of been closer to the coast because this trough doesn't line up with the storm. So what is there to really kick it out to sea when, you know what I mean? So like there's really nothing that could really kick it out to sea, based on, just all these type of factors and everything. And again, the main thing that's really bringing this back on shore is that the storm is moving extremely slowly. It doesn't catch on to this jet stream, and then that weakens. The storm absorbs all of that energy, and then an extreme ridge builds just above that storm. So the main thing is that let's see. Yeah, so that extreme ridge, that's a lot of high pressure, and that's going to bounce it away because high pressure doesn't like low pressure. They are the two opposite forces of each other, right? So you take a look at, the MSLP and precip, right? You kind of see how, this massive high and this high up here from Canada, right? And there's even more high pressure that builds around it because for everything that's low, there needs to be high pressure for it. You know what I mean? Same thing. Like, why are there winters where the East Coast is extremely like where it's like extremely cold on the East Coast and extremely warm on the West Coast, right? The same freaking logic with with pressure. And why is the East Coast, let's say, why is it wet when the West Coast is dry, right? Why? Because of the jet stream where storms follow, all that type of stuff. There's that's the negative, the dry, and then the positive is the is the wetness, right? And obviously here's the storm, boom, high pressure. It sends it on a type of track like Hurricane Sandy. So we have that going onto shore. Now if this was a little closer to the coast, that could be extremely possible because we're still extremely far out. And you know what I mean? Like if the models were showing it actually directly hitting New Jersey right now, that probably wouldn't even happen because you have to allow there to be some type of transformation for this stuff to be like more a little bit more accurate and everything. So again, we have so this is another model that kind of shows the forecast for Lee. This is one of the ensembles, and then we have the Lee again. Okay, you could just kind of see the hurricane. These are like the spaghetti models, I'm pretty sure. So yeah, Hurricane Lee current spaghetti models. All right, let's see this, right? So again, the cone is extremely massive. So here we got, obviously it's currently her, yeah, so look at this, like, look at this spaghetti model Lee's put in. Now we have more models that are now coming out a little bit, further west and everything, right? And I don't know how specific I could get here, but I really have intel. Trust me, guys. I know Mike's weather page. Let's see if this stuff is still active. And here you could probably see the spaghetti plots on how powerful it's going to be. Now, some models are definitely showing it's going to go back up to Cat 5. It's going to be moving over colder waters, but once it comes closer to the northeast, it's actually going to enter more warmer waters, right? And the waters are kind of chilly right now because of the displacement. I think it's like water displacement and stuff. But again, you see the spaghetti models here. There's a lot of them actually, and we just got to find which. Let's see. Hold on. We got the tropical intensity index. Where is Lee going to be intensifying? Again, it's going to enter an area of extreme intensification again because of the extremely hot, humid waters. And yeah, so we have all these factors in play, right? Shout out Mark's weather page. This is really coming in clutch. And then, that's it. So let's see. Number of named storms per 100 years. So again, here you could kind of see the usual track for storms and tropical systems, and obviously they rarely make landfall and everything like that, but now this is the thing. Look at that, like for real. But this is the 12Z GEPS. Look at the recent one. They're trying to BS you. Look at that. Look, the pressure extremely low. Freaking making landfall in New Jersey. In New Jersey. How insane is that? So please, everybody, keep an eye out for Hurricane Lee, and this is gonna be intense. This is gonna be insane stuff. So just please, keep an eye out for this freaking hurricane. That is insane. You take a look at these models, the 12Z, GEFS. Again, the curvature. Remember the high pressure there. Why are these models starting to show this? Why? That is insane. So I'm kind of just catching the trend here, but this cone could be shifting a lot further west within next, But again, forecast hour 108, what category would it hit the East Coast if it does? And at this point, because of the new model guidance and the storm moving extremely slowly, it's not going to catch the trough. So there's going to be high pressure that builds. That storm is going to intensify, all the low pressure going towards it. So let's see. So forecast hour 120 is how many days out? So 96 hours, so 24, 96 is 4 days out. 120 is 5 days out. And 144 is 6 days out. That'll be around when it'll be making landfall, right around here. So it'll be a Cat 1, most likely, when it would actually make landfall somewhere around, the East Coast, or Cat 1 or Cat 2. That's like a guarantee. So that's how everything is looking like right now. Again, probability of tropical storm force winds. Again, that's the current cone, blah, blah, blah. But this track is going to change a lot very, very soon. Please keep an eye out for all this type of stuff. And again, wind history, it's getting even bigger because that's what happens. Storms move over colder water. They get bigger over time. So that's basically my update for you guys today. I hope you guys enjoyed this video. Hope you guys can take something out of this. So hope you guys have a great day, and peace out.